In this video, I'll show you how to conduct a hypothesis test for a population mean. So in discussion board 9, you had to develop a hypothesis test either for a mean or a proportion. So the hypothesis test I provided as an example was about Montreal, specifically a neighborhood called Ville Marie. My null hypothesis was that the population mean for the price per night in Ville Marie is equal to $120. That means the alternative is that the population mean does not equal to $120. Now the significance level I am going to work with is 0.05 because that's the most commonly used one. But you can choose 1% or 10% or some other significance level if you want to try something different. Now I also need to find my sample size, my sample mean, and my sample standard deviation using the Airbnb data. So here's my Airbnb data file. And in a previous video, I showed you how to run the descriptive statistics using Data Analysis Toolpack for a price. Just as a reminder, if you click on Data, there's a Data Analysis Toolpack here. And under Descriptive Statistics, we hit OK. And that's where I would choose my price and run the summary statistics. So this was the data that appeared when I ran my descriptive statistics for price. So here are the three variables that we'll need. So I'm going to go ahead and plug in my sample size onto my worksheet. That's the 1,503 listings from my data set. For the sample mean, we can see it's $109.32. So I'll type in $109.32. And for the sample standard deviation, we have $259.84. Now I want to make sure I know what kind of test this is. So looking at my hypothesis test, because it's equals, not equals, this is a two-tailed test. For the degrees of freedom, since I don't know the population standard deviation, I'm going to find t test statistics and t critical values. So I need to know my degrees of freedom. That's n minus 1. So 1,503 minus 1 gives me a degrees of freedom of 1,502. Now note here, I've provided the decision rules for a two-tailed test, a lower tail test, and an upper tail test, as well as the formula to find the corresponding critical t-values. So since we're doing a two-tailed test, I'm going to focus on this rule right here. And so it states we will reject the null if our test statistic is less than some critical value or greater than some critical value, because for a two-tailed test, there's two chances of getting rejected. So here's the formula to find the critical t-value in Excel. And here's the spreadsheet I provided for Chapter 9 with all the Excel resources. So on this side is the critical value t when we don't know the population standard deviation. So as you can see, there's a lower tail, upper tail, and two-tail test. So I'm working with a two-tail test. I'll type in equals t.inv.2t parentheses. My alpha was 0.05, and my degrees of freedom was 1,502. Closing out, I get a critical value of 1.96. You might have more decimal places appearing, so you can just use the decimal mover here to get down to 2 decimal places. I put a note that for two-tailed tests, you have to have a negative and a positive critical value, so you can't forget, even though Excel only shows you one at a time. So for our decision rule, we will reject the null if our test statistic is less than negative 1.96, because the less than is on the lower left side and that critical value has to be negative. The other critical value will be positive 1.96. So we will reject the null if our test statistic is less than this negative critical value or greater than this positive critical value. Otherwise, we do not reject. In part B, we'll go ahead and plug in our variables into this formula. So let me show you briefly what numbers would appear. So for our sample mean, that's our X bar, that's going to be the $109.32 minus our hypothesized population mean. So that's over here, that's the 120. And for our standard error, that's in the bottom, my sample standard deviation is the 259.84 divided by the square root of my n. So my n is the 1,503. Closing out. So you can use a calculator if you want. Again, I always like to do by parts, but let's go ahead and do it in Excel. So here's my formula, and a reminder of the top is my sampling error and the bottom is the standard error. And so we did the sample mean minus our hypothesized population mean, and the standard error was our sample standard deviation divided by the square root. So to get square root in Excel, it's SQRT, parentheses, and here's my sample size. I could also just type in 1503, but it's just easier if I click it. And closing parentheses, I get my standard error. So plugging that in, we get negative $10.68. For our standard error, we get $6.70. Now, to divide these two numbers to get our test statistic, I'll do equals my sampling error divided by my standard error, and I get a test statistic of negative 1.59. This is rounded to 2 decimal places. So I'll plug in negative 1.59. Now I'll go ahead and make a conclusion based on the critical value method. So this is where I'm going to compare the test statistic in part B against the critical value in part A. So because our test statistic of negative 1.59 is not less than our critical value of negative 1.96, we do not reject the null. We also want to test the p-value approach to see if we get the same results. Since this is a two-tailed test, I'm going to use this formula right here. And again, that's right here, finding a p-value when we don't know the population standard deviation. So here's our formula for a two-tailed test. We'll do equals t.dist.2t parentheses. And while our t was a negative 1.59, with our two-tailed test, you just want to enter it as a positive value, and then comma, by the degrees of freedom of 1502, parentheses, I get 0.1120. So our conclusion is because our p-value of 0.1120 is not less than the alpha of 0.05, we do not reject the null. And if you forget, the decision rule stated right here. We will only reject the null if our p-value is less than alpha. That means the probability of that particular sample mean occurring is smaller than the alpha or the significance level that we selected. So because 0.1120 is not smaller than 0.05, we cannot reject the null. So if you have any questions, just let me know.